Hi friends, this is de-broglie studying BTech first year ECE in Johnson's Institute of Technology. Today I am here to discuss about validate de-broglie's contribution quantum of physics. Introduction. In 1934, Louis de-broglie introduced the idea that particles such as electrons could be described not only as particles but also as waves. This was substantiated by the way streams of electrons were reflected against crystals and spread through thin metal foils. One day in 1924, a young French Nobel managed to turn quantum physics on its head just as it was finding its feet. Even the most conservative physics were being to accept the duality revolution. Light is not only a wave but also behaves like a beam of particles, photons. As Einstein had established with his explanation of the photoelectric effect was earning him the Nobel Prize in 1921. Then Louis de Broglie's 15th August 1892 to 19 March 1987, a novice scientist whose first degree was in history. Through other, what if particles also behaved like waves? A century ago, there were still questions as attractive as this, to which one might dedicate a doctoral thesis. And that is exactly what we de Broglie did. After studying in depth of several years the basis of quantum physics established by Max Planck and Albert Einstein, he presented his thesis in 1924 with an important theoretical discovery. Electrons behave as waves, and not only that, all particles and objects are associated with matter waves. From Einstein's support to experimental demonstration, this is the well-known de Broglie hypothesis, putting together Planck's equation, quantization of energy E equal to hv, and Einstein's special relativity E equal to mc2. De Broglie calculated what the length of their matter waves associated with each particle would be depending on its velocity and mass. Thus, according to De Broglie, our whole world is quantum, not just light. A conclusion so bold that it was immediately rejected by many physicists and ignored by others. Although in 1924 his scientific career was still short when he presented his doctoral thesis, the French physicist had already done other research, which had led him to clash with some of the most influential physicists of the moment. Not so with Einstein, who enthusiastically supported de Broglie conclusions. But even Einstein's support was not enough to prove him right. His hypothesis had to be experimentally demonstrated. This is the diagram of artistic radiation of the wave particle duality. If the particle were if the electron were a particle that behaved like a wave, then it would have to show typical properties of waves such as diffraction and interference. And then some very strange things would happen. For example, one electron would be able to transfer to different holes at the same time. This was demonstrated by electrons diffraction experiment of Division and Germer. First step to the electron microscope. Few doctoral theses in the history of science has been so dazzling that they have reached the Nobel with the same work that gave the author the title of doctor. Another great example is that of Marie Curie. Incredibly, Louis de Broglie, with his first great scientific research, succeeded in laying one of the pillars of quantum physics, the wave particle duality, which states that waves can behave like particles and vice versa. From his idea of matter waves are born wave mechanics, the new formulation of quantum physics that Schrödinger developed to apply to atoms and molecules, and admitting the wave properties of electrons was the basis for inventing the electron microscope, released in 1932, which allows us to see things much smaller than typical optical microscopes. Permit because The wavelength of the electron is much shorter than that of photons of visible light. The above image is pollen grains. Pollen grains image taken on an electron microscope, an application of the de-broglie hypothesis. In addition, he was the first world's renowned scientist who called for continuous to join force to meet the great challenges of science in multinational laboratories. CERN, the European Organization for Nuclear Research, was born of this request and his long life. He passed away at age 94, allowed him to see the exponential achievements of his particle physics laboratory, inspired by his scientific vision. Now, about de Broglie's wavelength formula. De Broglie reasoned that matter also can show wave particle duality, just like light. Since light can behave both as a wave, it can be diffracted and it has a wavelength, and as a particle, it contains packets of energy hv, and also reasoned that matter would follow the same equation for wavelength as light, namely lambda is equals to h by p, where p is the linear momentum as shown by Einstein. Derivation. De Broglie derived the above relationship as follows. First one, E equal to hv for a photon and lambda v equal to c for an electromagnetic wave. Second one, E equal to mc2 means lambda equal to h by mc, which is equivalent to lambda equal to h by p. Note, m is a relativistic mass and not the rest mass, since the rest mass of the photon is 0. Now, if a particle is moving with a velocity v, the momentum p equal to mv, and hence lambda equal to h by mv. Therefore, the de Broglie wavelength formula is expressed as lambda equal to h by mv. Applications of de Broglie waves. First one, the wave particles of matter are only observable for very small objects. De Broglie wavelength of a double slit inference pattern is produced by using electrons as the source. 10 ev electrons, which is the typical energy of an electron in an electron microscope. De Broglie wavelength is equals to 3.9 into 10 to the power 10 amp. Second one, in a microscope, the size of the smallest feature we can see is limited by the wavelength used. With visible light, the smallest wavelength is 400 nm, is equals to 4 into 10 to the power 7 m. Typical electron microscopes use wavelengths 1000 times smaller and can be used to study very fine details electron. That's it about the de Broglie's contribution. Thank you, friends.